screen mode is okay?
Yeah, this okay, sir.
Yeah. In today, basically, and I think that is a tomorrow having the another session on the telemedicine.
Yes,
And
sir.
so in the telemedicine, basically, and tomorrow we'll discuss in briefly uh, in the help of the medical imaging perspective also. And today we will discuss the challenges and barriers to the development of the telehealth sector. And presentation is today we'll discuss somehow the importance of the telemedicine, telehealth, what is the issues and challenges mainly, and one case study related to the blockchain based telehealth scenario we'll discuss. This is some portrayal, self portrayal. They'll publish some related books, and I'm associated with uh, in the editors in different transaction and journals, and as well as book also. And before going to discuss uh, in details of telehealth,
Sir,
first we
sorry,
need
sir.
to
Sir,
go.
screen is not visible, sir.
Is it okay?
No, sir.
Hello.
No, sir. Still is not visible screen.
Not
Now it is visible, sir. You are at the fifth slide now.
which
Fourth
one?
slide.
Is it okay?
Yeah. Now it is moving.
Yeah.
Yeah.
Is it okay?
Yeah. Okay, sir. Now we are at
So
fifth.
yeah, but this is not a full screen actually.
Yes. Yes.
So so here in the Gartner chart, in the recent technological innovation point of view, what is the technological growth we need to study. So here basically time versus expectation, and here these are the curves, the graphical representations, the how different in the help of different technological features, how we are providing the best effort services to the patients. Because of that, we are discussing the telemedicine purposes. So here means the different computational platforms we have used. Here we have cloud computing, hog computing, and edge computing we are currently using for storing the data. But in previously means your yesterday networks by in yesterday's era you can say that is we generally store the data directly to the server end. But nowadays we are directly processing through the data to the cloud based platforms. So that's why this is the in different security aspects also. In yesterday's means we generally use we have been using means your in different encryption and decryption algorithms also. But nowadays that is we are considering means the cyber physical system and blockchain and others. So telehealth basically tele means your communication platform, and here that is we can transmit the medical by health data. So that's why telehealth can be categorized in three portions. One is your tele-education, telemedicine, and patient portal. Telemedicine also categories in three portions. One is your interactive patient care. Because of that, we need to provide some interactive information among the patients, among the doctors, among the service providers, as well as remote patient monitoring. This is the another important area, and tomorrow we'll discuss means in details that is what kind of based on means chronic wound imaging. In that time you will understand that is how to design the framework, and two type of another one stored and forward. So you know that is a modes of communication can be categorized in two portions. One is your real time basis, another one is stored and forward approach. So based on these approaches we can forwarding the patient-centric data, right? So telemedicine utilizes the information and telecommunication technology to transfer medical information for diagnosis, therapy, and education. And telehealth is used basically the information communication technology to transfer healthcare information for delivery of clinical, administrative, and educational services. And you know that is according to the National Center for Policy Analysis, and up to means your 116 million patients will be using telehealth services by 2024. Actually, this is the means wrongly I have mentioned 18. So telecare basically it utilizes belongs under the ICT platform. So generally been used to transfer the medical information for diagnosis and therapy of the patients in their place of domicile. Okay, mainly the rural information, rural patient-centric information, how to process the rural patient-centric information to the urban scenario or good nursing home and hospitals. Okay, and in the present scenario, by in today's networks, he says that that is in telecare, by in telehealth, teletrauma, so many means advanced topics are there. So in the help of the IoT, that is we can map uh, with the telehealth systems. So IoT and telehealth are combining to improve healthcare access and the patient outcomes, right? And you know that is IoT the most complex structure. If you consider the wireless body area network, but WWAN, in that case, our body consists of suppose multiple number of body owned sensors are there. So we are acquiring the information from the means your body sensor networks or body sensor nodes to the coordinator using the short range communication techniques. And after that, your coordinator is transmitting the data over the long distance communication, right? So IoMT mainly increases the human machine interaction, which enhances the real time health monitoring and patient engagement in the decision making systems. And this network is fully the connected devices, and mainly it is sensing the vital information in the real time basis. Vital information means this is the patient centric data. So that's why in this diagram you can see that the physician is there and your patient's party is there. So we are acquiring the data from the patient body, and after that this data can be processed through the several number of routers. Then your desktop means one app you can design it. After that your medical means tablet by any app type solutions are there. After that your means one data storage units are there. So that's why it's maintaining the electronic health record systems, and these EHR connected with the health cloud. Okay, and these data can be transmitted through the wireless means the short range communication techniques. Maybe you can consider IEEE 802.11, or you can consider is passive area network PAN .15 family. So .11 and .15 family IEEE you can use for transmitting the data. Such for example is the remote patient monitoring and tracking patient records and locations and collection of the data and wearable devices. So this is the in general structure for today's network, but today's infrastructure you can say in the help of this structure that is we can easily transmit the patient centric information to the means your cloud platform. And in this diagram here, you see that is your body sensor is there. The multiple number of sensor, but several number of sensor are associated with the body, and we are acquiring the data from but through the different sensors, and this data processed to the smart hospital, and this is connected to the cloud and fog services. The several other form is there, EHR, emergency service, connected home, dot dot dot. This is the layering structure basically in the IOMT. Means some solution basically. That's the three-layer architecture. You can say one is your lower layer here, that is a local patient system and controls can be uh, done. Another one is the device connectivity and device management is highly recommended for managing means your database solution and network devices also. Another portion, the upper layer, this is known as the analytical. It generally governs the analytical solutions like your server and cloud solutions, and based on the real-time analytics can be possible, data ontology, that data mining point of view. That is where you can that is suppose malaria spreading mechanism, predicts and predictive model, how to design it. So that's why this can be possible in through the upper layer of the means your IoT. Okay. Here that is in same case, that is for your app type design, you can access through the tablet. After that, your this is means your suppose OT kind of things. So patient centric, each and every step we can observe what is going on in the means your internal in the room actually basically. So this is connected to this means your billing structure is also associated with it, and maintaining the patient centric data, that means your maintains the patient records. Okay. So that's why with respect to the different patient ID, okay, so this is known as the patient PID name, you can say patient identification number. This is means you're the, yeah, this is the unique number. So based on the means your unique patient number, you can store each and every patient's history in the server. Okay. So that's why your identity server is there, billing application and transactions, and it maintains the patient records. And also the imaging applications are also involved in this scenario. And communication point of view, that is communication means, yeah, that is we are acquiring the data from the several number of sensors. And so after acquiring the data, having a two-step, one is your short range communication mode, another one is the long range communication mode. The short range, I already we have discussed, that is you can use IEEE 802.11 or IEEE 802.15 family. Okay, so that's why for faster means your faster data acquisition is needed, and after that this data can be stored in the coordinator end, and coordinator can process the data to directly to the cloud or fog based means database. So that's why this is the long range communication technology. So that's why the various communications models are involved from one end user to another end user. So that's why things means number of objects, and things mean numbers of objects, and things means number of means your devices and where we are acquiring the data. So that's why one is your device to device communication. Okay, like Zigbee, Bluetooth, I already told you dot 15.1 and 15.4 Zigbee. Okay. Another one is the device to gateway. Because of that, one end user to another end user, in between several number of the intermediate devices are there that belonging, yeah, means your among the such journey basically through the router basically. So that's why your this is the intermediate nodes, you can say. So that's why device to gateway model we need to design in proper way. Another one, the device to cloud communications. So because of that, this is the coordinator already acquired the data from the several number of nodes, and how to process the means large volume of data. And that is a patient centric data means you need to preserve the each and every patient's information. Another point is there, this is the backend data sharing model. So that's a backend data sharing model. And so these services also highly recommended for this communication structure in telemedicine systems. So more precisely, you can say that is a means your in this structure basically one is the sensing layer is there. Sensing layer means we are acquiring the data from the patient body, and this data is processed through the several number of routers or intermediate devices, or definitely the topology architecture. So many things are there. So that's why this is the internet layer, and upper layer means your data processing layer. Here, supervised, unsupervised, in this learning, but knowledge-based approaches, but data-driven approaches can be used in this case. So that's why for disease-centric informations, because of that malaria spreading and COVID. So that's why this is means the predictive model. So it belongs to the data processing layer, and that is in upper layer in the application layer. Here, that is a several number of applications. We are jogging, lifestyle, and self-management, CDSS, means abnormality detection by active and assistive living. So that's why based on the activity of the human, so that's why we can design in such a layering structure. Okay, so it will be better. A layering structure, we know that it is coming from the OSI structure, where the seven layer of architecture is there. But presently, that is a three layer of architecture. Lower layer means your sensing layer, and then your mid layer. This is known as the network layer or processing layer, and after that, your application layer. That means this is the mapping with the different several number of apps, right? One of the major means uh, contribution in the field of the robotics. So that's why telerobotics, telesurgery. Okay, so that means the medical robot is automatically doing some kind of operative features. So that's why how to track in from the real scenario, from the means your some distance mode. So that's why medical report mainly the interface between the physician and patients is based on the understanding of medical treatment itself and related to the biology and physiology and anatomy. And it is categorized in three portions. One is the surgeons, hospital, and patients. So surgeons mainly improve the patient care, enable complex tasks, and true life and 3D visions, enhance the in dexterity and superior ergonomics, comfortability, uh, seated posture, less blood loss. So many points are there in the hospital, mainly focusing the increase the efficiency and potentially reduce cost. Cost is the one of the important parameter. Another one is the potential reduce the litigation and marketing tool. Patient-centric point of view, indefinitely we need to concentrate on that is how to compact in the shorter hospitalization and reduced pain and faster recovery times. So many points are involved. So that's why in the help of the three section, basically surgeon, hospital, and patients, that is in telerobotics is the one of the important features. As per the Da Vinci principle, you can say that is in connection that the permitted surgery can be to the to be performed with the surgeon at a console means at a distance from the bedside robot to the patient in the operation theater. So it permits the surgeon to perform the surgery to the another room, another building, or another continent. So that's why that they provide the expert advice like teleconferencing and teleradiology and telepathology. So that's why see you can observe from this diagram that is here that is as per the law means the Vinci principal point of view. That is these are the surgical procedure and that is as per your direction your robots that is in manually they doing some kind of OT works, right? And here you see that one doctor is there. This is the gallbladder operation of the 68 years old patient in the Strasbourg in France. And he did so when the remotely operating the surgical robot arm. So that's why as for his direction that is automatically the robots can do this kind of the surgical operations, right? So that means you this is the robotic surgery technology, and here the Da Vinci in the patient side cart, and you see that is one is your endocrist and the controller is there, and three console. One is the 3D vision and master controls and camera control is there. So that's why one is the center column is also associated with the instrument arms. So that's why, as per doctors advise these robots remotely means doctor basically is from remote, but in the operative in operation theater in robotics and plays a big role for doing this kind of the OT works. But advantage and as well as the disadvantage also because of that cost is another important issue, and this is the means very much highly recommended systems and high purchase and maintenance cost is too much high. It requires the cultural shift in the hospital, increase the space of procedure and operating rooms, and that is a stiff learning curve and also lacks the tactile and force feedback. Operating may take longer due to the setup, no additional insurance to offset the higher cost. So these are the drawbacks as there, and you know that each and every technological model, but technical model proposed model in that time, you see that it having a two parts. One is your advantages, features, another one is the limitations. But in definitely you need to focus on your advantages part, but in limitation, and this is keep in mind, and that is a try to mitigate, that is a try to sort out that is how to solve, how to minimize the cost and how to improve the efficiency of the proposed model. This is the means your prosthetic scenario, like in the dealer microsearch and robotic surgery system. Here, ultimately, the ambition of the robot supported the surgery on beating. That means this is the structure basically, and here there is automated systems we can design, and this is the future trends and development. That is how arm works. See, this is your manual, and this is your artificial. How it works. So based on the proper decision making unit, based on the your prescriptive but directive natures, it depends on the directive natures, you can say. Telehealth, that is one is the mm, major issues there. First, we need to studies as per your means your presentation. That is, we need to discuss what is the challenges. So challenges and barriers, and definitely is there. Having means many till now that is not purely implemented because of that. Having so many drawbacks is there. Like one is your regulatory and the legal issues. In regulatory and legal issues, you see the licensing is a big problem. Licensing by cross-state licensing. Another the privacy and security concern. The privacy and security, in that case, your healthcare providers need to ensure the compliance with the privacy laws and such as the HIPAA, Health Insurance Portability and Accountability Act. In the USA, another one is the GDPR, General Data Protection Regulation in EU. So these are the important things, and then belongs under the privacy and security concerns, right? Another one, the reimbursement of the payment policy, like many insurance companies or government healthcare programs, and may not cover the many telehealth services rely on high-speed internet and advanced devices, and which may not be available in rural and under served areas. And another one is the digital literacy. So the lack of the familiarity with the telehealth tools and can hinder the effectiveness of the virtual consultations. So you know that is in older population or those with a low tech literacy may find it the difficult to use the telehealth platform, right? Another one, the interoperability. So healthcare systems often use the different software, database, and electronic health record systems. So that's the interoperability, the another issue. So that means this is means access to technology, digital literacy, and interoperability. This is the three section belongs under the technological challenges, right? Another part is the means infrastructure limitations like internet connectivity. Another one means the lack of healthcare infrastructure in rural means your remote areas. Remote areas, this is the one of the biggest issue because of that for establishing the means your healthcare infrastructure basically. So you need the costly the main portion. Okay. Fourth point is that this is the resistance to change, like cultural and institutional resistance. So there may also be institutional barriers such as your outdated policies, procedures, and lack of training. So your so many experts are required for acquiring the data, for maintaining the data, for capturing the proper images from the patients. So that means your expert is required. Patient resistance, patient who are means the associated to traditional face-to-face visit. They are very much interested to face-to-face visit, but in that case, that is not possible because of the through the video mode that is we can uh, communicate with the means the doctors actually. So that means trust is another issue in telehealth services. Another one is the enhancing trust and transparency in telehealth transactions, like verifying the healthcare providers. First, we need to verify that is how many providers are there. So, which one provided the better services uh, during the treatment modalities. Because of that, we were not only forwarding the patient sending information to the doctor. By the end of the day, your doctor's opinion is very much important, and this information can be processed to the patients also, and vice versa. Another one, the transaction transparency. So in this portion is also highly recommended in telehealth but telemedicine sectors. But this is still in the nascent stage. So that's why more concentration is required for verifying healthcare providers in transaction transparency point of view, right? Second is addressing the cybersecurity risks. So in telehealth is susceptible to the cyber threats, including the data breaches and hacking and identity theft. So that's a blockchain is the one of the issues, and I will show you that is how blockchain enable telehealth platform that is how to solve the issues. And blockchain mainly provide the several features that can reduce the risks. One is your encryption and security mechanism. Another one is the decentralized nature. Next, your resilience to the data tampering. So that's why based on the three uh, categories that is in blockchain plays an important role for mitigating the risks. Okay. Next one is the pharmaceutical and the prescription tracking. The blockchain can also improve the medication management and the prescription tracking in telehealth sector. So that's why it track the prescription history and medication supply chain transparency. Another one is the anti-drug counterfeiting. Next point is the research and data sharing for medical advancement, like your secure data sharing for research when collaboration across the borders. Okay. Next, the different stakeholders are also associated with the telemedicine, the health platform, like one patient, patient not only belonging to the rural area, it is also moving to the also belonging to the urban area also. So that's why patients from the diverse regions. Okay, so we need to grasp up the all in patient-centric information from the means so diverse regions. So that's why these are the one of the vital challenges. And expert doctors are there, and doctors directly associated with the expert clinic and nursing home and hospitals also. Next, telemedicine technicians, and another one is the paramedics, administrators, teleservice providers, and pharma industry, insurance sector, policymakers, law implementing agencies, law agencies, and licensing agencies. So that's why these are the important stakeholder for telemedicine, means your telehealth sectors. Legal point of view, that is a for patient, that is a privilege to expertise the availability. That means this is the one of the important portion belong under the legal aspects. Then reimbursement, and second for doctor's point of view, the credential for the telemedicine treatment. Hmm. Another one, the access to the patient data. Patient data means this is the vital information. So each and every clinical data is carries the means higher value. Okay, we need to preserve the each and every patient centric data. But when you are accessing the data, that means your legal permission is required, and this permission can be provided by the service provider. So that's why access to the patient data. Another one, the standard protocols. Because of that, for source to destination end in between so many means intermediate gateways are involved. Okay, so each and every gateway, that means you need to check that is a properly standardized, yes or no. Standard protocols is needed. So that's why protocols, that is a set of rules that governs the networking. And networking means this is the path, but this is the infrastructure. So that's why that carries the means your telemedical information from rural to urban area. Next, your remuneration is required for service provider and administrators point of view, the cross-border licensing and instrument maintenance regulation and remuneration. So that's why here there is a three portion basically. One is your for patient centric, for patient point of view, for doctor point of view. Another one is the service provider point of view. So that's why means three sectors are there. So you need to map by you need to combine the three sectors, and these three sectors is jointly provides the better facilities to the means your telehealth related legal aspects scenario. But on the other hand, the ethical aspects, what do you say the ethical aspects? So in that case, you see for patient centric, that is a privacy and confidentiality. Another one, right to appeal the required treatment, expertise, informed consent. So these are the means the important areas that belongs under the patient's side. So that's why your ethical aspect you need to maintain. For doctor side means your responsibility of treatment. Number two is the data used for the treatment and research. Next, your privacy by confidentiality maintenance. Uh, Next, your commitment to meet the patient directly if needed. Then, your local condition adaptation. So that's why these are the different areas belongs under the uh, means your doctor side, or on the other hand, this is the service provider in admin sector. The service provider in admin, you see that is in a cross-border cultural or language differences in the consideration. So that's why in the telemedicine, you know that is for your app, if you design the client side by patient centric app, so let's say in that case you're definitely some different language, because of that in different states, different regions under the states having the different local language. So that's why your language conversion is one of the factor, because of the doctor only means receiving the data by receiving the information through one common language and giving his uh, feedback to the same language also. But we are acquiring the data from means different peoples, right? So different people mean different languages associated. That's why your multilinguistic scenario is there here. But this is also the cost-effective solutions. Okay, you have to convert that is in 10 or 20 local language to the English language, if you say. So that's why your cross-border cultural or language differences considerations. This is the ethical aspects, and another one the responsibility for right transmission of the conferencing of data and storage consideration of the doctor expertise and availability and willingness. Okay, suppose if you want to visit means suppose CMC Velodo. So in that case, suppose one particular doctor is XY, but in that time he is not willing to or take care this call, means your. So that's why in that time that the patient can unhappy. Okay, means our intention is that we want to contact with this doctor, but he is not there. So that's why the patient satisfaction point of view is the main part. So that's why patient and doctor and as well as your service providers and admin. So that's why three are most important sectors that belongs. Then those need to follow the means your ethical aspects point of view. Admin aspects here that is in clear terms in condition pertaining to transmission, recording and storage of sessions and patient data. Then your regular maintenance and upgradation of instruments and softwares, then providing infrastructure and manpower to both ends of telemedicine network. So infrastructure and manpower, this is the two important part. Okay. So your infrastructure and the manpower and both ends in telemedicine networks that you need to establish. Then your capacity building. Another one is the creating awareness among the masses and the health providers. Next, you're conducting classes or training programs for health workers and technicians also. As standard protocols, this is the belongs under the admin aspects, then charges and remuneration and cross-border licensing. So that's why these are the important point we need to keep in mind that is when we're discussing the challenges, the barriers of the telehealth sector. Next to information and privacy related issues, like you know that we are forwarding or transferring the patient centric data from rural area to urban area, right? So in that case, we need to preserve the patient centric information. So that's why knowledge to patient by acceptance of the virtual consultancy by patient, by written consent we need to take for immediate use or future and categories use of the information. On the other hand, means of privacy during the teleconsultation of patients at both ends. So that's why we need to provide the proper the privacy mechanism. Uh, so that's why one patient information. So that's why I told you that we need to provide, we need to generate in the help of the RAND function that is your unique patient ID okay, PID num. So that's why each and with respect to the unique patient ID, we can store the data in the database. Okay. Next, we need to maintain the confidentiality and data integrity also. So that's why patient data confidentiality during the consultation and transfer and storage. So that's why we need to maintain the confidentiality and integrity issues, right? Next, the enlisting the practitioners for telemedicines. So let the patient also choose his doctor. In that this portion we have discussed in the last slide. Because of that, in the most of the patients in nowadays they are finding based on the review they are searching that is which doctor is better, and they are trying to communicate with this particular concerned doctor. But is suppose in that time he's not available, so that's why the patient can the demoralize. So that's why better that is your both the understanding is required, the availability doctor, the availability of the other set of doctors we need to focus. But till now that is in this portion is not there because of the telemedicine. In the present scenario you see that each and every means not every nursing home by every hospital, we can't say, but the means most important town-based hospital or nursing home, they are generally using their own telemedicine systems, right? This is not either in the globalized scenarios. This is not implemented yet. Next, that is enlisting practitioners for telemedicine and let the patient also choose his doctor. Another one, the information in India is not integrated with technology as in the Western countries. Okay, so that's why that is a information, patient-centric information. When we are passing, when we are forwarding this kind of patient-centric information, we need to preserve the privacy issues and strictly. Okay. Next, security in generally, you can say that is it having the few portion like your security means your trust is the important issue. Trust means we need to set up the trustness. It allow only the design people, the service, the device, but data access point of view. Another one is the identity issues. Identity means it's validate the identity of people, services, and things, and privacy that is ensured device, personal, and sensitive data is kept private. Next one is the protection. It protects the device and user from harm. Another one is the safety. It provides the safety for devices, infrastructure, and people. And security, the maintain security of data and device and people also. So that means the security in general, we know that is a, and during the transmission, we need to provide the better security mechanism. So in that case, that is a, you can preserve the ICT also. Telehealth and blockchain, we are discussing some little bit of the blockchain platform. That is here you see that is integrating blockchain technology with telehealth can help the address and some of the critical challenges in healthcare, such as data security, privacy, interoperability. And here you see the opportunities like your transparent and reduced transaction time, secure and cost efficient and irreversible transaction. And this is the opportunity and main challenges is the interoperability. And that we have already discussed that is the interoperability issues with another part, and then that is the scalability issues. And storage unit means storage means stack wise because of that we can process the data in the help of the means your unique patient ID. Okay, so each and every patient's having their unique patient ID, and if you search means the database with the patient ID, and you can easily get the patient history. So that's why how to manage the patient history. So that's why with respect to the patient ID that you can easily find out, and as well as you can store the data with respect to the patient ID. So that means this is dealt with the storage unit. Another portion, the social acceptance and require the standardization. So that means your these are the major issues involved in the blockchain technology, like interoperability, like scalability, like storage and social acceptance, and require the standardizations. But among means on the other hand, that is it provides the telehealth and blockchain. It provides the transparency and transaction time, security, cost efficiency, and irreversible transactions. In that point of view, that is we can say that is a blockchain-enabled solution. It provides the better response to the means the medical sectors. In this sector, basically, strength and weakness and opportunity and threats, basically. So, strengths, basically, the cost efficiency and speedy access to the medical data and autonomous and temper the proof information sharing. Or weakness means there is a less number of software and system vendors and involved in that case, but no, not much scalable, but or you can say that a lack of storage capacity for the large amount of data. But large amount of data means means we have already discussed because of the patient-centric data means that each and every data is the vital. So we need to preserve in that kind of data. But opportunities means lower fraud risks in the medical supply chain. Beneficiaries get more control over the data, potential for startups and for with partnership in healthcare, and anonymity of the data and will help of the medicinal research purposes. But different threats are also involved, like hesitant social adoption of technology and non-standardization, cultural and trust concern to adopt the blockchain for sensitive data. Another one, the interoperability issues are also involved for the blockchain-enabled healthcare systems. So IoT means and blockchain. So both are directly associated with means the tele health systems. So IoT mainly the chronic condition management and blockchain the supply chain traceability and recall. IMT mainly used for the medication adherence, but blockchain used for the uh, credentialing, and it is also looking for the claims education. But in IMT is concentrating the remote patient monitoring. Remote patient monitoring means you see that is here already. Uh, Means your telehealth, but telemedicine already involved in that part, and asset monitoring also. But in blockchain, mainly looking for the health plan enrollment, a health plan claims, transaction, credentializing, and traceability and recall. These are the parameters, right? And last portion is IMT mainly used for the clinical research and blockchain mainly payers and provider B2B collaboration. So that's why in that case, that is you can easily differentiate, but you can easily observe that is how IMT and blockchain works under the telehealth systems. This is the one work basically here you can see means your secure health record with blockchain federated learning you have applied. So that's why in that case basically securing the health record, mainly the EHR, how to secure, how to preserve the patient-centric information in electronic health record systems. So he introduces the blockchain-based lightweight encryption strategy with federated learning to address the scalability and trust concerns of the EHRs. And next, you see after implementing the lightweight encryption, the EHR data is stored in a decentralized cloud system. That's a very good design. We have done this work 2 years back, basically last year actually. So here we got very good response. That is for lightweight encryption techniques. That is it provided the better uh, results for storing the data in a decentralized mode. Another the importance of the protecting privacy and security of the distant patients health records is explored. Next, your guarantees will encryption throughout the whole conversion with the federated learning. Okay, and to ensure the data is private between the owner and user and during the contract's execution, and it employs a very effective proxy re-encryption mechanism with the federated learning techniques we have considered. Next, this is also the compared with the existing algorithms and proved to be the secured model. So major concerns are involved basically security and privacy concern that relevant in the IMT, and it presents the difficulties for firms and using the innovations and security, privacy, accessibility of the patient information are all the danger when several medical systems are used And definitely several medical systems, several medical instruments are used. So that's why accessibility is the major issue, right? Next, availability, data integrity, and privacy are all at risk if security is compromised. Uh, this is a very dangerous point. Next, hackers. Hackers is the common is nowadays. You have already familiar. So hackers may also use the blackmail or extortion to coerce victims into disclosing the medical information, and they would rather keep private, right? So that's why your accessibility, privacy, and security of IoT enabled health tools like your fitness trackers are major considerations. So that's why we focuses on proposing the blockchain-based techniques for privacy preservation and security of smart EHR of patients using the lightweight encryption interface with federated learning model. So here is the last line. So many points are associated with this, but each and every means your each and every point having some meaning. Because of that, this is the blockchain-based techniques mainly used for the privacy preservation. That is true. Next, having the security of the smart EHR. Nowadays, people are talking about the smart system, smart design, smart model. Smart means that is a proper decision making units or highly recommended systems, right? So that's why decision making system. Each and every sector you need to take the proper decision. So that's why smart EHR of patients using lightweight encryption interface. Because of that, we have used lightweight encryption interface systems and with the federated learning model, federated learning, but collaborative learning model that is OEKD. So that's why each and every works in basically that is you need to consider means what is the challenges involved for during the communication, during the preservation of the data, preservation of the medical data. Right. Next, the contribution. Contribution means that each of patients may be accessed from it means any location and with the help of cloud scalability of and low cost, and as well as its many mobile access points are involved. So to preserve the sensitive patient health data, it proposes lightweight encryption model interfaced with the federated learning to maintain the privacy, security, and data. So electronic health record proposed technique compromised with the front end and back end modules, and front end developed with single web app, and back end developed the Ethereum platform through the Internet of Medical Things device with the growth of the secured access strategy for a cloud-based web applications for health information, and the modules are interfaced with the smart contract where IoT sensor are involved. So mainly the present means to prevent the message tampering, replay, and man in the middle attacks, as well as the guarantee the data secrecy and message recency. The proposed protocol with the federated learning keeps network is very much safe. So in this proposed model, proposed system model here, you see that is your application layer means your upper layer is there, next your network layer, next your perception layer is also involved. So that's why here encryption means why? Encryption means we are receiving suppose plain text and then the secret key that is generated by the KDC, and there's a mix typing the data and then generate the ciphertext. This ciphertext data can be processed through the public channel. After that, using the decryption algorithm that is you can reconvert it to the plain text information. So that's why patients' identities and medical records and images are supposed to be safeguarded in an IoT enabled infrastructure. Number two, the conceptual foundation for security paradigm of medical images in the IoMT presented here. Another one to further improve the complexity of the computation. So that's why this is the based on the major concern, based on the major concern. So that's why we have designed in this model and lightweight encrypted model using the federated learning. It provides a very good response. Okay, and these data can process through the different layers that already we have discussed, like your perception layer, and network layer, and your application layer also. Another point is that is your complexity and computational complexity and computational time. You can say that is yeah, this is the one of the important area. Because of that, you need to minimize the complexity of the model. You need to minimize the required computational time. Okay. Next, patients are required to transact using the smart contract. Next, Ethereum network considered in place of the backend support systems. And these following functions, like your patient private key will grant the doctor access of the systems. Because of that, your private key and public key, means your patient public key and only give some sort of permission to the doctor. The doctor can access the patient private key. Because of the doctor need to check patient's clinical history, clinical data, and as well as his imaging part also. So not only not only checking for in general clinical information, this is not a good way. So because of that, on the other hand, that is in patient history management. Okay, your PHR, patient health record, patient history management. Suppose 10 years back, one patient having some kind of problem, and present scenario is that is a patient facing the another type of problem, but doctor can easily check that is what is the previous history. Based on the previous history, that is a doctor can prescribe in a superior way. So that's why patient, doctor, and service provider, all sectors having their own key, but patient private key means will grant the doctor access to the systems. Number one. Number two, patient will share their private keys with the physicians, and patients may safely and securely exchange the sensitive information. Sensitive means your vital patient information. So based on your clinical information and based on your means your imaging, suppose one patient having some ulcer images. So your time to time, but different type of images means your visual information is required. So doctor can observe, okay, this kind of problem is there. But you are transmitting not only the clinical information, because of the clinical information can be stored in the means with respect to the patient identification number, but also you need to maintain that is you need to observe how to process the medical images to the means your telemedical platform. So this is the main point. Because of that, here the if your channel, because of channel means your channel access means your bandwidth is required. And if you consider means your Shannon theorem, it says that is a capacity equal to bandwidth into log of 1 plus SNR. So capacity over bandwidth equal to log of SNR, log of 1 plus SNR, and capacity over bandwidth means the bandwidth efficiency eta. So bandwidth efficiency and power efficiency, uh, both are highly recommended for any kind of medical information processing to the channel. So that's why your hospital administration has limited visibility into the procedure, and they can keep the communication system running smoothly. Another one, the website is currently undergoing the front end development. So using the master smart contract, it communicates with the server side. Okay. So one is the client side, another one is the server side. One is the front end, another one the back end. Right. Then intelligent contracts are in the back end of our infrastructure. So a log will be kept in every alteration and made to the block. So block-wise information, because of that in the blockchain means the total each and suppose source to destination in between 10 or 15 means your gateways are there. Gateways mean blocks. So each and every block, when after receiving the patient setting information, they are encrypted and then processing. So that's why each and every block that is checking their security platform. So that's why definitely the end of the journey, you can see that is you will get means the original information. You can't say original, but this is the reconstructed information. Like your original is FX, and this is equivalent to the reconstructed. That means f dash x. Both are equivalent. So that's why these are the points basically for how to design the back end, how to design the front end, and how to share the means your private key of patients to the doctors. So these are the important scenario, right? Next, here that is a process of securing and preserving the electronic records using the blockchain technology interfaced with the federated learning model. So here see that here you see that the patients and doctors are there. So patient created account and sent and get data, and this is the connected with the hospital. And this create and send and get data is connected to the blockchain network. So that's why that is a to start seeing a doctor, prospective patients need to create an account and fill up their profile with the basic information. Basic information means this is the clinical information. And after submitting the form, and doctor will consult with the patient. And after doing an online search or for relevant medical records, and next after consulting with the treating physician, the hospital will update the patient blockchain network profile. And blockchain network with federated learning model is integrated into all procedures via the online portals. So that's why that is a process of securing, how to secure, how to preserving the electronic health records using the blockchain technology, and this is interface with the federated learning because of the different tasks are involved. Okay, why federated learning? Why we are choosing the federated learning? Because of that, the multiple number of tasks are involved, and we have chosen the major tasks. And based on the major tasks, we need to characterize the data. So characterize the data means your proper classification is needed. So that's why in the faster and efficient model when we are designing, we're going to design that means your efficient model. So in that case, your proper characterizing or proper classifying techniques are required. So that's why the federated learning it provides the better response for managing the sensitive patient-centric data. So main purpose of implementing the proposed model using means lightweight encryption. This provides the low computational complexity and uses the less memory and consumes the low power, resulting the securing the data. Another point is there it exchanges the encrypted using the patient's public key, and only the patient's private encrypted key may decrypt it. And all Ethereum nodes are secured using the proposed mechanism. So that's why in that case your lightweight encryption techniques that we have applied, and end of the day we have observed that the computational complexity is very much less. It takes the minimal time and also uses the less memory, or it consumes the means low power. Power requirement is very much low for securing the data, and it is exchanging the means your patient's mm, uh, private key to the doctors in a secured way. And last point is that is Ethereum nodes are secured using the proposed mechanism. Right here, that is a certificates with the blockchain-based proxy re means encryption method, which is made of the 7 polynomial time procedures we have used. So 7 polynomial mean you the setup, certified user key generation, encryption, re-key generation, re-encryption, decryption, and your decryption also. So that means these are the means features basically. This is the feature point of view, and these data is marched with the means user key generation. This is the command basically to certify steps into the single and unified process. This is called the certified user key gen, right? So that means this is the certificate. So this is made up, which is made up of the made up of 7 polynomial time procedures. Okay, and these are the features that I already discussed. Here are the encryption and decryption steps. See, this is the start. Next, your encryption. Data encryption is required. Encrypted data can be stored in the data storage unit. After that, your images are there. .bmp, .jpg, you can choose, no problem. After the encryption process during encryption process, like your plain text is coming, suppose, and then key generation, key generated from the KDC. So they are mixed up, and finally, this is means produced the cipher text. All right. On the other end, your encryption and parallelly for the decryption also. Ah, so that's why your encryption, plain text, and KDC generated data is ciphertext, and decryption side, decryption, data storage, cipher images, and your decryption process, then KDC, at ultimate the means your end of the journey. So that's why this is the flowchart of the encryption, decryption implementation in the proposed technique for securing the electronic medical record systems, right? So in that case, your blockchain, IoT sensors, and a cloud server mainly used to store the data. System shows the system architecture is feasible. Here, that is a three IoT sensor we have used, three mining machines, three Ethereum full nodes, and two ordinary users, and one cloud storage server we have used, where the flow of the encryption and decryption is considered. Next, to set up the everything and made sure it was linked with the web. Because of that, your app means your accessibility is required. That means web-based platform is required for this kind of work. So Gates auto discovery protocol utilized to establish the communication between miners and the full nodes, and Google Firebase Cloud was set up for the data storage purposes also. So that means these are the how it works basically, how system, how lightweight encryption mechanism, data learning based lightweight encryption mechanism can use, can provide the better solution. So that's why these are the required solution. Means your requirement basically. You can say this is the requirement, and each and every technological portion and having their own features. Okay, but we need to integrate it. Smart contract has the capability to register sensors as a smart contracts. We are discussing this several times. Smart contracts basically has a capability to register the sensor and appeal the data and handle the financial transactions. Next, each TI sensor tag CC2650 means communicated with the Raspberry Pi 3. Next, Ethereum wallet and ECC secret key is both stored in the app. Encrypted sensor data and metadata uploaded to the Google Firebase in JSON format. Next, RSA algorithm is that the data which is encrypted with the public key can only be decrypted in the affordable time by using the private key also. So that means last these two slides basically, what kind of technology involved for this work and how to interconnect, what are the solution, right? Here is the results. Suppose table in this table that is you see security of round function on the text and images. This is the key size. Key size in bits which is varies like 64, 128, 256, and 512. And text is because this is the value actually. Text and as well as your images. The sum of the brute force items is united. So that's why this is represents this table represents the encryption decryption time for image and text and that are evaluated in different bit levels and key size in this one. So that means this is the security performance on the text and image data. See here is the in general mean encryption decryption time for the medical data. Your key size is there. Encryption time is also with their number of block size. Mentioned in here. Suppose you see the 512 bits on the key size. Here encryption time 145 millisecond and block size is 1512 bits, but decryption is 147 milliseconds. Okay. Next, image entropy used to measure the distribution of the grayscale images, reflecting the amount of data content in the images, and your RSA and ECC self-organizing tree algorithm, SOTA algorithms are compared with the proposed technique for four different images, like your cover image, image one, image two, image three, image four. Here, ECC mean electric car cryptography. It provides like 6.8, 5.9, and this result. RSA percentage wise 3.2, 6.0, 5.6, 4.3 like this. SOTA 7.1. That means this is the value 4. SOTA is the slight variation basically. So that's why 7.1 is. And finally, the proposed light encrypted method it provides means 7.8. Uh, so that means your security performance of the proposed model is seen to obtain the better result respectively when compared to the existing algorithm. These are the existing algorithms, basically ECC, RSA, and SOTA. And your results here you see that is for range 0 to 70, and the different parameters like your PSNR and your ECC, PSNR of the proposed here image 1, image 2, and image 3, and average value. So here you see this is the peak signal to noise ratio comparison of the ECC algorithm and proposed techniques for three images in the average of them. So that's why this algorithm basically based on the lightweight encryption and with predator learning is effective for securing the e-health record of patients, right? Next, security performance of the proposed model is seen to be the improved compared to other existing algorithms because the implementation of the federated learning techniques. Here range and as well as you see the what is the variation image to provide the better response. So mean squared error means comparison for ECC algorithm and the proposed techniques for three images and average of them. So that's why in the proposed structure and they are provided the better response. So in this work makes electronic health management more intelligent and secured by introducing a system that is inflexible in design and but transparent in all its financial dealings. And next year process of securing and preserving the electronic records using the blockchain technology interface with the federated learning model is protected and from the unauthorized access and any alteration to the data content inside. And here entropy of encrypted image is assessed using the proposed algorithm and compared with the existing algorithm ECC, RSA, and SOTA. And proposed algorithm obtain better results and when compared to the existing algorithms. So PSNR, MSC are also analyzed for the proposed algorithm and ECC algorithm also. And storing copies of chain while keeping the indication of the existing in the blockchain and federated learning. And future directives, here you see that is for medical insurance in the one part. Then medical insurance means that is a clear outlines for the teleconsultation insurance. Another one is the cross-border issues and should be governed by the international body. Next, your international means the standards, interoperability. So standards of the equipments and teleservices, periodic checks and submission to the regulatory authorities also. Next, your instruments and services like liability maintenance and safety, licensing, the authorization and capability to the service provider, telemedicine laws and IT laws of the information stores, storage and access. Next, e-health portal and the regulation and governance. And for social media such as apps, SMS, and telephonic consultations. So in that case, you see, means your several number of future directives are involved for the telehealth sectors. So we need to focus in a superior way for establishing the networks, right? So today, basically, we have discussed in what is the importance of the telemedicine, and we know that is a, how to manage the patient-centric, how to manage the patient-centric data, mm, how to transfer the data. So that's why through the different modes, through the different means channel, what kind of means agenda will occur. So that's one is the data acquisition, data processing, Another one is the data analytics and data visualization. And we need to preserve the patient-centric information. That means it's a vital sign. We need to preserve and telemedicine and telehealth, teletrauma. So many points are there, and there so many sectors are there, and they are providing the tremendous supports to our society and having some sort of drawbacks or limitation, and definitely in future uh, and we will overcome, and definitely that is in our population we get benefited from their services, intelligent services. So, and as well as in today means we are also discussed around the importance of the blockchain, how to secure the data, how to preserve the patient-centric information. So, and as well as how to share the means your patient private key to the doctor. So these things we have discussed. I think that is all of you having a much knowledge. So just we are interacted. We are interacting because of that. This program basically deals with the telemedicine and telecare, and I am very much thankful to Dr. Budati because of that. He is thinking. He thought that this kind of topics is very much important for in today's platform.
Yeah, thank you, sir. So, participants, do you have any questions? It is an open platform for you. Any questions from participants? I think no, sir. So thank you very much.
Sir,
Yeah, please.
sir, can we use fog computing to provide the security rather than blockchain? If so, then how?
Please
By
repeat
using
once.
cryptography encryption method.
Madam, please repeat.
Sir, can we use fog computing to provide security rather than blockchain by
Uh,
using symmetric or asymmetric encryption scheme?
uh.
Can it provide the same security?
Maybe it depends because of that you were talking about the which computing? Fog computing.
Computing, yes, sir.
So fog computing versus blockchain.
Yes, sir.
Yeah. Fog computing means this is the means when you are processing the data to the means you are the cloud platform. Cloud platform. So that means at a time you can apply means your security schemes. But for blockchain means that is a separate that means it's a supply chain model. So it consists of suppose 10 blocks are involved. So each and every block there individually works for providing the better security mechanism. So that's why this
Okay.
is the more advanced and for efficiency point of view, uh, mm, efficient transmission of medical data to the cloud in that point of view that is edge computing but fog computing provide the better response. Blockchain belongs under this structure. Here that is a different blocks are involved, each and every block having their key structure. They are
Okay.
generating the key. So that's why each and every block doing their own encryption and decryption mechanism. So that's why end of the day you will get the better outcome when you are considering the blockchain.
Okay, sir. Thank you, sir.
Is there any other participants? Yeah, thank you, Chinmay Chakrabarti sir, for your insights for about telemedicine and telehealth industry.
Okay, thank you, sir.
Yeah,
Thank you,
thank
sir.
you, sir. Thank you. So, dear participants, we are uploaded in the AICTE ATAL portal about yesterday and today's session chairs. You want to give the feedback. So after end of this program today, you can give the feedback as well as yesterday attendance I have already posted. So I am downloading from the attendance from the Telegram or this Teams, and based on the sorting the data, I have given the attendance. So, and coming to the your test and assessment, it will be done by the last day. So we will share all the material. So that is the PPT what shared by the the presenters. I will share to you in our in WhatsApp group. Based on that, just we will conduct the test and assessment. So based on that, you will download the certificate also. So today, second session is given by the Rajnikant Alvel Garu, Symbiosis University Director, so on the artificial intelligence impacts on the telehealth and the telemedicine industry. So the session will start by 7:30. So the 5 minutes of break after that, we can start the session. So welcome Rajnikant sir.
Yes, sir. Thank you.
Yes sir. Shall we start the session, sir?
Yeah, we can start.
Yes.
1 minute. Just
Yes.
I'm downloading my presentation.
Okay, okay. Sir.
Yes, sir. We can begin.
Yes sir. So dear participants, so for the subtle FTP second day, second session, so the topic is artificial intelligence impacts on telemedicine and telehealth industry. So this session is taken by Rajnikant Alvelu, Director for Symbiosis, so Institute of Technology. Before going to the session, so I'll give a brief introduction about our today's speaker. So Professor Rajnikant Alvalu is an accomplished professor with a wealth of 21 years of experience and contributions in the field of computer science engineering and academia. He is currently working as Director of Symbiosis Institute of Technology, Hyderabad campus, Constituent Institute of Symbiosis International University, Pune. His extensive tenure as a professor, coupled with his leadership roles in reputed academic institutions and professional organizations, reflects his commitment to education and research. Holds PhD in computer science and engineering, specializing in cloud computing. He holds IGIP International Engineering Educator Certification, practices OBE, and believes in interactive learning through the use of technology and innovations in pedagogical practices. So Dr. Rajnikant, he serves as a member of the Board of Studies for various institutions. He has a strong understanding of NBA and NAC accreditation process. Professor Rajnikant demonstrates a strong foundation in both theoretical knowledge and practical expertise. His significant publication record comprises over 150 research articles in various peer-reviewed journals and conferences. He edited 7 books for Springer, Digwander, CRC, IJ Global, and AAP publishers. He edited special issues for Springer Soft Computing, InterScience, IJDATS, and SPCE journals. He is the recipient of the Best Faculty Advisor Award from the IEEE Hyderabad section, as well as the IUCEE Faculty Fellow Award in 2018. He is a life member of ISTE and a member of ACM and MIR labs. He served as a resource person for various technical programs, FDPs, etc. He has organized various international conferences and delivered keynote addresses. So with this, so warm introduction, we are cordially invite Rajnikant Alvelu garu. Please take over the session, sir.
So, thank you very much, sir, for warmly introducing me to the participants.
Thank
And
you,
with this, I'll take over the session. Yeah.
Yeah.
So, dear participants, I welcome you all to this particular ATAL FDP, which is majorly specializing about the advancements in telemedicine using IoT and artificial intelligence. So for the next 1 hour, I'll be talking about use of artificial intelligence in the area of telemedicine, telehealth, and its impact, as well as where exactly this particular telemedicine and telehealth is going to land up in future by taking advantage of the current artificial intelligence or the generative artificial intelligence which the people are talking about. So let me take a minute to share my presentation. Yeah. Hope my screen is visible now.
Yes, sir. Visible, sir.
Yeah. So guys, let's first understand what telemedicine is all about. And as well, let us look at the COVID-19, the it's, during COVID-19, the impact of telemedicine, as well as the role of artificial intelligence in the telemedicine. So when we look at telemedicine, we should not look at that telemedicine is possible only with artificial intelligence. But of course, the telemedicine can be improved with the artificial intelligence. So now, telemedicine is nothing but where we use technology to deliver the healthcare services remotely with the minimizing physical interaction. So wherein providing the health services or the healthcare services to a patient or to a sufferer in a different geolocation where the doctors or the healthcare providers are not available. So we call this as telemedicine. And in fact, the birth of telemedicine has taken place because of the revolutionary changes that have taken place in the communication media. So in fact, whatever the current technological disruption which we are practicing, like the real-time sessions or the real-time communication, everything is just possible only because of the communication. Like people talk about cloud is because of the broadband communication channels that are available. So of course the communication systems have become are the backbone of the telemedicine. And as well, the telemedicine was there to some extent before COVID-19, but during COVID-19 pandemic, as we all know that everyone feared for death, to connect to a patient, to reach out to a patient. As well, we all know that the patients have moved into a quarantine and wherein they have required the health services, wherein a doctor or a nurse to reach out is a challenge where the telemedicine has really served. And now, today we are going to talk about the role of artificial intelligence in the telemedicine. So we are going to talk about its impact in various domains, in various dimensions, but the basic impact will be on the patient monitoring, intelligent diagnosis and assistance, healthcare and IT improvements, and automation of the administrative tasks. These are the four major tasks, and in fact, I will discuss few of the case studies where these are already possible with various AI-enabled applications available. So already I discussed what is telemedicine. It is remote healthcare delivery using digital communication technology. So now what exactly it includes when we are talking about digital communication is a channel, but there should be some gadgets that we use. So it involves smartphones, it includes the messenger applications, webcams, biosensors, smart implants, etc. as well. This FDP is more going to talk about IoT. In fact, IoT is the one which lies in between these gadgets and the digital communication technologies. Sometime I will talk about the cloud stack as well. In the cloud stack, how IoT is there and how AI is going to be a part of cloud stack, and how we are going to get this, telemedicine services. So the key benefits, as we know, enhanced access to healthcare, right? Sitting somewhere in the remote place, we are able to get access to the most specialized doctors, right? And we are also going to get versatility in care, right? So versatility in the sense, so we can, get, controlled by different doctors taking first opinion, second opinion, third opinion, etc. And the other one is the time, convenience and timeliness. Need not wait. The patient need not wait for the doctor to reach out. Okay. So, or the healthcare specialist to reach out. So we are able to get in the time, and we are going to save a lot of vacuum time, which is involved in for the doctor to travel to reach out to that particular patient. And for that, we have various software solutions, and these solutions include the prediction or the prescription or the cognitive solutions in place. As these days, we are also talking about robotic surgeries as well, which are a machine operated surgeries. So now, just as I said, how an architecture looks like. So a patient, just by using smartphones and web cameras, okay, through the sensors or some kind of wearables, okay, so is connected to a healthcare application server. The healthcare application server will get its inputs through these particular gadgets from the patient. Okay. And what healthcare application does, it stands as an intermediary between the healthcare specialists, the physicians, or maybe the doctors, or anyone else. So this way, remotely, by using a smart gadget, the required, health facilities are provided. The healthcare facilities are provided. But now, what are actually the challenges in healthcare? Okay, so which we can address by using this particular telehealth. When we look at the world's population is growing, but at the same time, the number of healthcare specialists are not growing in the same way. Say the very first one is about the aging population. So as we know that the lifespan also has increased because of the current, healthcare conditions, right? The people average age has increased, and now we are actually going to have more and more older people, and they require healthcare support, okay, and which is again going to be an increased demand. When we talk about older adults, making those older adults travel is a challenge as well. One side we have the deficit of the healthcare specialists, physician shortage, as I was talking about. And there are extended wait times. As we all know that whenever we reach out to a doctor, every time we are going to have a long waiting queues. A doctor who is really an expert will have a long waiting queue, and we reach to the doctor when we are suffering. And at the moment when we are suffering, we need to wait for a doctor, which is again a suffering on the top. The next is the healthcare workforce strain. The other side, one side, we are saying that waiting is a challenge for us, but doctors are overburdened with the kind of patients, okay, with the count of the patients. So that's another challenge. The next one is about the financial pressure. So when reaching out to a doctor or the healthcare specialist physically, definitely will cost us more. The rising costs, which are always going to be a challenge. Okay, so even people say, if any patient reaches a doctor, he has to spend all his savings to save his life, which is going to create a financial burden. Now, the solution for all these challenges is nothing but the telehealth adaptation. So, which already we spoke. So, remote patient care, efficiency, and scalability. A physician can address more number of patients, okay, than the number of patients he addresses physically. So, scalability definitely comes over here, right? And say, for example, uh, the doctors are spread across the country. A doctor at a place might be overburdened and a doctor at the other place might be least occupied. Then he can take over the demand at a place where the physicians are not available. Okay, so this telemedicine, right, can take advantage of AI solutions, okay, to overcome the patient care which we are talking about, efficiency as well as scalability. But here we need to have an understanding of artificial intelligence. So what is an artificial intelligence? So it is nothing but when we are talking artificial intelligence, so means something, there is a natural intelligence which we have as a human being, and the intelligence, artificial intelligence means nothing but we make the machine intelligent. So how do we make the machine intelligent? By learning. So it learns from the past data and it becomes an intelligent machine by using which it is able to predict, it is able to take some decisions. So that's where AI as a subset takes advantage of machine learning, takes advantage of deep learning, as well as takes advantage of NLP to become a conversational AI. So here the machine learning takes advantage of the data that is already existing, okay, and learns from the data that is already existing, and it is able to develop a pattern, and by using that particular pattern it is able to predict, like say for example, by learning from the data, it can develop a pattern of a symptoms and can say that the disease that you are suffering from, and it can tell whether you are at what situation you are, whether you need to require to consult a doctor or whether you can take some medication or some care. So now coming to the conversational AI, the conversational AI, as the term says, that the AI can, it's an application where we can talk as if we are talking to the other human being, and AI application can understand the human language, will interpret and will take decisions and will respond to that particular patient, just like how Alexa does, just like how your Siri does. And for the conversational AI, we take advantage of another, mechanism, that is the NLP. So that is natural language processing. So that's what we talk about, the conversational AIs. So not only the conversational AIs, at latter part we will talk about using explainable AI and generative AI at latter part as well. So because of this, what is the benefit that we are going to get is, we are first, as I already mentioned, the time savings and improved efficiency and accessibility and scalability. So the AI solutions for the healthcare shortages is an advantage. So means what I mean to say, the difference between a telemedicine and AI, in the telemedicine, we require a doctor to be available online and to address the patients. But here, when we add AI to this particular telemedicine applications, we do not require a doctor in place, because now AI will learn from the data, AI will learn from the symptoms, and AI is able to prescribe, AI is able to predict, AI is able to take decisions. So means slowly we are eliminating the doctor. Okay, eliminating the doctor for healthcare. Now imagine, in the last slide, I was talking about the shortage of healthcare specialists. Okay, but now when AI is introduced, when AI can serve to an extent, then the actual doctors or the healthcare specialists can be used for the challenging health situations. Otherwise, AI can provide the required solutions to the patients for the troubles. So now what happens? We are going to have huge time savings. We are able to overcome the shortage of the healthcare specialists, and it's highly scalable as it is an application. It can handle n number of patients. Now, looking at the telehealth market, see here, guys, do not get confused. I'm sometime using telemedicine and sometime talking about telehealth. So telemedicine is something just talks about your suffering, your medication, your symptoms, etc. Telehealth talks about even educating the people to be safer side, educating the people to be how they can be healthy. Okay, it's a larger perspective. We talk about the health overall picture. So talking about an individual, even when he is not suffering, is what health. Telemedicine is something which we talk about only when someone is suffering. Otherwise, we can use it interchangeably. Do not get confused. So now, how this telehealth market is going to grow in future? So it is expected to reach some $590.6 billion by 2032. Okay, and currently it is just $63 billion. So imagine the kind of growth the telehealth market is going to get in the future. Say, if you just imagine the world has 100 crore population in the year 2000, and by 2024, now we are around between 700 to 800 crores. The population is getting multiplied, right? And the kind of services the population requires are huge. And that's where the technology is the solution. And in fact, AI, which is an artificial intelligence, is the need of the hour. So then you can look at the digital health market size for AI technologies to grow from, it is currently $11 billion and it is going to grow up to $188. So we are talking about impact of AI. See, in fact, the whole telehealth or telemedicine industry is going to be disrupted by using the AI technology. And the whole AI technology efficiency depends on the kind of learning happens from the data that is available. Okay, so what are the key factors for driving the growth? As already mentioned, it's increasing accessibility and expanding the cloud platforms. We are talking about cloud platforms here. And AI API based services and telemedical devices, like, we see that OpenAI, we talk about Llama models, etc. Various AI APIs are already in place, which are helping us when we require as well in various domains. And high demand for AI powered telehealth solutions is currently there and is going to come as well. If you could see now, currently everywhere people are using continuous glucose monitors, for checking for their diabetes, etc., and which is actually monitored from an application, and where remotely a doctor is going to observe. When a pattern is identified, the patient is going to get a message, right? So they're already in place. So now the benefits are, it supports physician for decision making, and of course it can eliminate the physician too, and it improves the delivery and the patient outcomes, reduces the administrative burden. But the challenges are the trustworthiness. Of course, whenever some technology comes in, people do not easily trust it. Say now, imagine if you reach out to a doctor and gives a medication, see the kind of trust that we are going to have. And imagine a application giving a medication, definitely there will be a challenge of accepting the trustworthiness on that. Okay, using that particular AI tools, and balancing availability as well as cost of those tools, as well as there is a need for compliance with the clinical frameworks. See, when an AI application serving, there should be a compliance that yes, this application can be used. This application is trusted. So there should be some compliance that should be existing that is actually missing even at this point of time. And but what people believe at this point of time is a physician guided implementation. People believe that some manual intervention is required. Okay, so people are ready to accept telemedical or telemedicine telehealth services remotely through a physician, but in the absence of physician, people are not ready to accept. As well, the healthcare providers also need to be given an enough training to understand the use of these applications. This is something missing. So that's why we need to have an adaptable and reliable frameworks for AI integration. So the other benefits are, geographical barriers can be overcome. We save time, health risks, proactive healthcare. So this already we discussed. Okay. So nothing much to. So it's revolutionizing the healthcare with AI and telemedicine. So already we discussed these points, right? So we are going to get the best care because we are able to reach the best doctor remotely. Okay. And we can also say that even visuals can be shared. Okay. So these are all again, so we can have screening and diagnosis, chronic disease management, etc. This already we discussed. So let me move ahead. Yeah. So already I spoke this, right? Telemedicine versus telehealth. It is nothing but telemedicine talks about healthcare services through technologies like video conferencing, etc. And telehealth talks about even education and medical record management, etc. These are the key differences between telemedicine and telehealth. Of course, can be used interchangeably. Let's look at a detailed framework here. So earlier we were talking just about a patient, right? So a patient through an app and through reaching out to that particular specialist. But the telemedicine has to support it in a various situations, right? The patient can be at met with an accident on road. He can be in a rural health center or a community center. It can be at his home. He might be traveling. He might be in an ambulance, and then still, the medication has to reach out to that particular individual. How it reaches? As I began explaining, it is the communication channels that helps. So this particular application should be connected through the communication channels. They can reach out to the doctor, it can reach out to a hospital, it can reach out to some intensive care unit, it can also reach out to some patient monitoring place. And in fact, you all know that every individual who is suffering from some health situations regularly gets diagnosis. They have a lot of data with them, but at the time of emergency, they could not travel, carry their data. And the doctors, has the data is not available. So for doing the treatment, it causes some delay to that particular doctor there. But yes, if the patient diagnosis data is all recorded, and if the moment when the patient reaches, if the data is made available to the doctor, the medication will begin at a very quicker time, and saving the patient becomes easier for the doctor by understanding the situation of the patient. So the technology plays a very, very vital role over here. Okay, so looking at the apps, so you can see how this AI is going to interfere in between. So AI always gets the input, means it understands the symptoms, and correlating between the symptoms, it comes to a decision. So combination of the symptoms will help AI in going for a decision making, and through that it responds. So these symptoms and a combination of symptoms, the AI actually learns from the data that is already available. So we already discussed about the challenges of integration. Some one is the safety, the risk of algorithm errors harming patients. I'll give an example. These days we are talking about robotic surgeries. Robotic surgery in the sense wherein remotely a robot remotely controlled, or sometimes a robot autonomously itself is doing a surgery. Say for example, if a doctor does a surgery and he fails with the surgery, so doctor gives us an explanation that why the surgery has failed or was failed. But if a robot does a surgery and fails, what is the situation there? The robot is controlled by AI. So that's what risk of algorithm errors will definitely harm the patients. So here there comes a need of another kind of artificial intelligence, which we call it as explainable AI. People talk about using explainable AI in healthcare. And explainable AI, the term says that the artificial intelligence uses white box models. We understand the protocols followed by that particular AI, the algorithms followed, the decisions taken by the AI in implementing that particular processes. So that's why the risk of algorithm errors can be resolved to some extent by using explainable AI. Regulator complaints already there, as we already discussed about. Financial challenges for the infrastructure. Of course, when the infrastructure is made available, uh, it comes at a lower cost, but procuring that particular infrastructure definitely adds cost. Capital expenditure will be more. Operational expenditure will get reduced with the AI technologies. And there is also a challenge of some ethical issues, because being a machine, if it is trained for a bias, definitely it lacks transparency, and it might go for doing something wrong. Okay, so let me skip this. The key challenges are technological access. See, you know, telemedicine is dependent on communication channels. If the communication channels are not available, so definitely the telemedicine also becomes deaf and dumb, right? And the workforce limitations, the people to use this particular application is also, AI applications is also a challenge. And sometimes cultural and language barriers as well. See, for example, a patient is suffering somewhere in the remote part of the country in India, and an expert doctor is available somewhere in UK. So the patient fails to explain his situation, and the doctor fails to understand. So the communication barrier will be definitely a challenge for the telemedicine, wherein a local doctor can understand the language, doctor can understand the situations and can take it forward. As well, certain parameters, health parameters like blood pressure, glucose levels, or various other parameters, the parameter thresholds differ from country to country. This is another challenge. Okay, so in India we consider a particular blood pressure level as a common. Okay, but whereas others do not. In a different country, it will be a different parameter threshold there. Okay, so cultural and language barriers is also always a challenge for a remote telemedicine using artificial intelligence. There will be a data security concern as well. See now, countries talk about their security. Health security is also very much important for any country. So they do not want to uh, share the health data of a country, because you know it is also going to create lot of challenges for the country, because people safety is of people health is also of first important for any country. So the data security concerns always will be there, as our complete health data is available at remote, so we lose control on our uh, you know health data. Okay, so financial constraints, as already we spoke about, the potential solutions are using NGOs for this is a solution. Now here, role of cloud computing in telehealth or telemedicine. So these days we know that when we are talking about using technologies like AI, they require a complex IT infra behind. As we are all talking, as I was talking about, procuring that IT infra is always a costly approach. So we have an advantage of taking from the cloud computing. So cloud computing is a utility computing. So we can get the complex computing infra required from the cloud services. So AI can take advantage of those cloud services and can provide the telemedicine systems or applications or services to a user at a lower cost. And in fact, we were talking about IoT networks. So we were talking about a cloud stack. In the cloud stack, we are going to have cloud on the top, which we call it as a remote computing. Then we are going to have fog below that, which we call it as a local computing. And the fog is connected to IoT, which is nothing but we call it as edge computing. Otherwise, we can call it as a thin computing. Say, for example, these days, most of the data is collected by using IoT sensors, wherein if the computation required is very less, therein with the help of those edge computing or the thin clients, the decisions are taken. If they require more complex computing, then it goes to a fog computing infra. And if they require more complex computing infra, then it goes to the cloud. So we call this as a cloud stack. Cloud will be on the top. Next to the cloud, we have fog. Next to the we have IoT. IoT is nothing but called as a nearby computing or the thin computing we call. And say like, if I want to know the temperature, the weather report of the place where I am, my sensors are going to sense it. And I do not want a cloud infra there. Simply, my sensors will sense or will get to know that weather report and will give it there itself. Okay, so that's where based on the kind of computation we use these cloud services. Okay, so in fact the telehealth requires the complex computing infra, complex processing power as well, and a quicker processing power as well. So that's why the telehealth takes advantage of artificial intelligence, and artificial intelligence will take advantage of the cloud computing. As we all know that cloud computing provides the services which are 99.99% 24/7 available. Okay, and the data will be available, the processing power will be available, and that's where telehealth can leverage the advantage of cloud computing. And these days, if you talk about cloud is also coming with various kinds of services. Okay, earlier it was only infrastructure, platform, and software as a services, but now even AI as a service is also coming up from cloud computing. Robotics as a service is also going to come from cloud computing. So that's why people nowadays call X as a service. So artificial intelligence is itself available as a service. And as we could see that Google is working on this telehealth services or telemedicine services, no doubt in the very near future, we are also going to get health as a service or healthcare as a service from cloud computing. The days are very closer. Okay, it's not so long. The way how you are accessing your email, how you are accessing your Facebook, LinkedIn applications, we are going to get our cloud service healthcare applications. So at your doorstep, at your palm, by using your mobile, you are able to get the first-hand health support. Okay, so examples are, we're talking about AI diagnostics. Okay, I was talking about real-time glucose monitoring, health, virtual health assistance 24/7. The same is again an example. And telemedicine platforms are also there. Like if you could see, Apollo has their platform, right? We could see that various other platforms are also available. Who does our, continuous follow-up? Say that, if you purchased a medicine, it will tell that after 10 days, your medicine is going to be completed. You reached out to a doctor after 1 month, you have to go to the doctor again. So it always keeps you reminding as well. Certain, those applications are already in place. Okay, so the other one is about chatbots, right? So now we have more, the chatbots are already in place. Okay, so the chatbots also helps us in getting the first-hand information, okay, whenever we require. And the way so far, most of you are maybe using chatbots for your banking services, maybe any other services that you are looking for. Similarly, the healthcare enabled chatbots are also available. And these chatbots initially were just on the data and the questions that are already available, but now the chatbots are also enabled with the generative AI applications. Sorry. Okay, so let me take up some case studies here where the telemedicine with AI, okay, is serving. So the very first case study is about tele-ICU. ICU is nothing but it is an intensive critical unit. So whenever the patient is suffering from some acute issue, then he or she will be under ICU. And as we all know that every hospital is equipped with an ICU, but most of the patients actually, die or lose their life before actually they reach the ICU. So now here we are talking about a tele ICU, means we are not going to mobilize the patient. Okay, the patient will be at his place, or sometimes a patient will be traveling, but his treatment starts, his care starts from the place where he is, where the doctor stays at a remote place. And in fact, tele ICU is something which already was in place from the COVID-19. So what it says, remote monitoring and management of critically ill patients using electronic communication. Okay, so how this can be done? So now when we are talking about tele ICU, so it says that there will be a center, like the way how we have a police command control room from where they monitor whole city. So we are going to have an ICU, which looks like a data center, and they keep remotely monitoring a good number of patients, not one patient, a good number of patients. So they will be looking at the patient, they'll be looking at their parameters, conditions, and they'll be giving the required, medication for them. Okay, so the key benefits is enhanced clinical outcomes, reduced mortality rates. It shortens the ICU stays and optimize resource allocation as well. Okay, and most of the times we also experience that people may not get a bed in ICU. Sometimes they are suffering and go reaches an hospital, and because of the kind of population that we have, we may or may not get a bed in ICU, where again the mortality increases there. So a case study is Clive AI-based tele-ICU solution, which was started in March 2020. So where it is deployed? It is deployed in Sheba and Saursky medical centers in Israel during COVID-19. So they expanded the facility and safeguarded healthcare workers. Here, they want to save the people sufferings, but at the same time, they also want to safeguard the healthcare workers as well. So that's where they have come with this particular solution. It has AI-driven patient features, and they did a great service. So look at here. This is the model of Clio AI-based tele ICU. So look at here. So they are able to look at the diagnosis reports. They are able to monitor the conditions. They are able to look at the patient remotely, and they're able to give the prescription as well. So various monitors by using which they're able to monitor remotely a patient. Okay, so this is how the tele ICU is monitor. Is a case study, is a representation model of the telemedicine, which was in place way back in 2020. And imagine the kind of impact this particular tele ICU has created during COVID-19 in Israel, and how they could safeguard their healthcare workers. Now we talk about further talk about the ethical concerns in AI implementation for tele ICU. So here it says over reliance on technology. Say we know how important an individual's life is. An individual while suffering, okay, critically, we are dependent on a technology. Okay, and technology may go wrong, may go right. If it goes right, everything goes happy. If it goes wrong, then the kind of mistake, the kind of guilty that we face. Okay, so that is because of over reliance on technology is what actually the challenge. Okay, the risk of neglecting human expertise and clinical judgment. Yes or no? Now, when we are talking about applications, who does monitoring, who does decision making, and who eliminates the human expertise? So there is definitely, we talk about over reliance on technology. But imagine, right? We travel by a flight. But are we not relying on technology? Yes, we are relying on technology, and we are traveling by flight, because the only outcome is we are able to reach the destinations in a very quicker time, saving the time. Yes, and we are relying on technology. Technologies will definitely experience certain challenges when they newly come for, and over the time when they grow, they get the acceptance of the people. But as this at this moment, it is a over reliance on technology. The next, algorithm bias and disparities, as already we discussed. So it's a machine, we can guide it the way we want. So definitely a bias can be introduced. And transparency and trust is missing, and training and education is also something which already we discussed. So we have another use case over here, which we talk about telecardiology, which is similar to that of tele ICU. So this majorly talks about, you know, monitoring a healthcare patient remotely. So his health related conditions, her health related conditions, you know, AI keeps on monitoring his ECGs and cardiac imaging for early diagnosis, and it will tell the doctor about the situation wherein a patient can be immediately mobilized to an hospital on an emergency. So there will be some wearable devices. So the wearable devices keep continuously monitoring the health rate, glucose levels, etc., and can tell. Okay, so they also do predict and go for a decision making. Yes, this patient requires a mobilizing. Okay, so this where the telecardiology is also going to work, and where the role of AI is there. Telestroke is also another example. Okay, so where we talk about how do we know that a stroke happened? Just through some diagnostic reports. So when the symptom says that something is wrong, then immediately, the concerned information will be passed on to a doctor. Okay, it helps in decision support, pre-hospital notifications, etc. will come. And for this, there are certain platforms like Aspects is a platform, Rapid AI is a platform. They help us with this particular telestroke. Okay, so a simple example he has given, Medtronic and Zydus hospitals in India for AI-driven stroke care. So they are already collaborated with these particular hospitals, and they were supporting for this particular telestroke. Okay, so we also have teleurology is another one where again it's same. So we have certain tools. You can see Euroscore. We have Paki, which is a Cleveland clinic. So they also help us in the kidney kind of treatments. So this is a case study which is already in place for the telemedicine. Okay, so we have more such applications. You can see UCLA Health Systems, USC Institute of Urology, Cleveland Clinic, etc. So see, like the way more sufferings are for heart in India, there are more sufferings of kidney relevant in the Western countries. So they have more applications there which do continuous monitoring of the kidney injury or the kidney health conditions there. We call it as teleurology. So now, so far we are just talking about use of artificial intelligence. But now, as we know that over the past 5 years, once the chat GPT has come in, people were more talking about generative AI. Okay, so now we also need to look at how this generative AI is going to impact on telehealth and telemedicine in future. See, when we talk about generative AI, so AI is going to generate, it is going to generate the text, it is going to generate information, okay, from the data that is already available. And this generative AI, most of the times is a conversational AI. So it generates the text in a human readable form. It even required, it can generate a voice in a human readable form. And we get the feeling as if we are talking to an individual, right? So with the generative AI, so what we get is enhanced diagnostics and decision support is what actually we are going to get. So how do we get? Say like when we reach out to a doctor and when we are suffering, we go for a diagnostic, and the diagnostics will give certain images. From the images, the generative AI model will learn the symptoms and will uh, tell us that the kind of suffering that we have, right? It learns from the images. Okay, so for what happens, we go to a hospital, the diagnostic center, get some reports. Of course, they give some symptoms. We reach to a doctor, and doctor, by looking at that, will tell us the situation. But now Just even the symptoms are not required. If the images are available, we have AI models in place who will find out the differences in the image and will tell the current situation of the patient. And we have case studies for that, real-time systems in place. AI doc is one. AI doc is a real-time example of uh, for enhanced diagnostics and decision support. So next we have improved patient monitoring and the risk prediction. So I was talking about there was a challenge of cultural and geographical barriers like language barriers. But of course we have translators here, right? So whatever the language that you know, you can talk in your language, and your language gets translated into the language which the healthcare specialist can understand, and a patiently remote remotely a patient can be monitored, and the risks can be predicted, right? So for that we have in generative AI solution with name Livango. Okay, so the Livango, how it does is it can analyze from a wearable devices. So the people are going to have some wearable devices with them, and the wearable devices includes various remote sensors, and the sensor senses various parameters which goes through an AI application, and AI application with the kind of data came and with their earlier learning and the patterns will come up with a solution, right? Will predict whether there is a risk or whether it is whether there is no risk, etc. So for that we have a case study that is Livango. So then moving on, the personalized treatment plans. So for that, say for example, everyone would like to have, so we should not go in general for every patient, because may someone is suffering from a fever but he has various other health complications. There is another guy who is suffering from a fever who is not having any other health complications. So we can't go with a generalized treatment plan. Of course the plan need to differ from patient to patient. Yes, so for that we have another case study which is Tempus AI. So a simple example, and this is one which is used basically for the cancer treatment. So then we have for automated patient interaction and engagement. We have a case study with name Babylon Health AI. So this is a chatbot which is basically used for the primary care. So people can use this particular chatbot for interacting and understanding the situation. So basically, like the infant healthcare, where a mother gets quite often issues, very simple issues, for which they will be in a confusion whether to reach out a doctor or not. In all such cases, the chatbots really help. Whatever the little query that have, they can put it there and the chatbot immediately responds. And of course, they get relaxed, right? So that's why a Babylon Health AI chatbot is one which really helps for the primary care. Next is operational efficiency and workflow automation. See, now the healthcare industry means not only a doctor, there are various people works behind, right? So uh, and a patient will be handled by multiple set of people, and the data has to move from one person to the other person, and there should not be any communication vacuum. So that's why we need to have a clear workflow automation there. Workflow procedure should be there, and it should be automated when we are talking about telehealth and telemedicine. And a very good example is Redox. It actually streamlines the complete electronic health records. So because, say for example, if a mistake happens, one patient record goes to the other patient record, the whole mishap happens. So that's why the healthcare records has to go in the flow it is defined to go. Yes, so that's why we need to have certain solutions, and Redox is an example for that. So we can see more case studies are there. So building trust in AI-driven healthcare decisions. We have IBM Watson Health in oncology. So this is another solution that we have. So what it does is it helps the patients and the clinical experts to trust AI recommendations by providing transparent and understandable reasoning behind automated decisions. So it gives an explanation. I was talking about explainable AI, right? So This is how the impact of explainable AI on the telehealth and telemedicine. So once the patient gets convinced, or the patient caretakers gets convinced, we actually accept the technology to be used. So IBM Watson Health is one that really helps. Then we have the improved clinical decision support. So for that, Path AI is a solution that is available, which again uses XAI in the pathology majorly. So it enables healthcare providers to make better informed decisions by explaining AI reasoning. So far, earlier case studies, nowhere I am mentioning that there is an explanation of why a certain decision is taken, why a particular process is adapted. But here, there is a reasoning and mentioning about why a particular procedure, why a particular decision is clearly mentioned. So Path AI is a solution for pathology. Okay. Uh, Next, what we have is Google Health AI for retinal disease detection. So this is for, again, which talks about regulatory compliance and accountability. So what it says, so it meets strict regulatory standards, and XAI will help ensure that AI models are transparent, fair, and accountable, which is crucial for compliance with healthcare regulations. So it's like WHO regulations, etc. That particular app is going to follow. So the Google Health AI for retinal disease detection, nothing but the eye disease detections. So it's a case study that we can see, which is already in place. Okay, we can always experience that as well. Then next we have, already I use this example when I'm talking about use of generative AI. That is a Babylon Health AI chatbot, right? And the next we have is Apple Health's AI for cardiac risk prediction, which reduces bias for and ensuring fairness. So these are all the various case studies available to understand the impact of artificial intelligence on telehealth and telemedicine. So when we are looking at AI, just do not look at the traditional AI, but also we need to have to look at the use of generative AI, use of explainable AI, use of conversational AI for the telehealth and telemedicine and their impact. And by looking at these case studies, no doubt we can say that the telehealth and telemedicine has a huge impact with AI, and we can't separate them as well in the near future. So we talk about education on telemedicine and AI. So of course, this is really required for the people, because people have to accept the telemedicine and AI, so that one side we say that we are not accepting, the other side because of acute shortage of healthcare specialists. So we have to adapt this to reach every corner of the world. So people need to be educated. And telemedicine and AI in healthcare, as we said, there is a transformative potential, and we are seeing that particular transformation, and it's going to be further increased in future, and there is a lot of scope for doing research. Okay, so the future scope is role of physicians will be totally occupied by AI capabilities. Say for example, I'll give you an example. Say these days when you go to a doctor majorly dependent on diagnostic reports, because when you talk to your elder ones at your home, they say that at the time a doctor, just by looking at the pulse, okay, he used to tell the sufferings, he used to go for medication. They do not have diagnostic reports available to them to treat a patient the way that are available today. But imagine down the line 10, 20 years, not just the diagnostic reports, but a doctor will be assisted by an AI agent, or may doctor will be replaced by that particular AI agent to serve, or to support the patient, or to support what I mean to say, the suffering. So that's the place where we are going to go for, and AI engines are growing. And but in fact, to say the current day AI, people are talking about a buzz about it, but the current day AI, I call it as only narrow AI. So there is a future AI which we call it as broader AI or general AI. but to get a general AI, it takes a lot of time. Okay, so the world definitely is going to get the into that general AI, but currently we are just working only with a narrow AI. Narrow AI means an AI engine which is superficial or which can perform with best efficiency only for a particular task it is mentioned for. Say, for example, I'm using an AI engine for driving, it does only driving. It can't serve as a healthcare expert. But if I have an AI engine for supporting like healthcare only for cardiac, it does only that. So that's why AIs are narrow, not the general AIs, so which are broader AIs, which takes a lot of time. But uh, yes, there is definitely a lot of research going on, a lot of scope there because of the acute shortage of the healthcare specialists, the way that the population is growing enormously. So there is always space for telemedicine and the telemedicine using AI. Okay, so now people need to know that mostly many of you might be the teachers or academicians doing research. You might want to know certain research areas where you can work on in terms of this telemedicine or telehealth using AI. So these are the various areas you people can work on. So using of AI in diagnosis and decision support, you can look at automated diagnostics, you can look at clinical decision support systems, you can look at AI for remote monitoring. So looking at natural language processing in telemedicine, so you can look at automated documentation and note taking because the patient, while the patient is getting treated, even the patient records need to be documented, which a machine can do it automatically. So where sentiment analysis for mental health. Okay, when we are talking about healthcare, so we can also look into that mental health of the patient. Clinical chatbots and virtual assistants is the area where you can work. So like that, we have various areas you people can look at. Like we have telemedicine for acute care and emergency response is an area where you can work for. So AI for triage and prioritization, again, decision support in remote emergency care. So these are the various, areas where you people can work on, and every statement over here is a research vertical, and there is a huge scope to work on them. So you can look at telemedicine workflow optimization. Okay, so there are more. You can look at telehealth for rural and underserved populations. How do we give the access? So this is something, an area here where you people can work. Looking for personalized medicine and precision telemedicine. The precision agriculture people talk, like precision telemedicine is something where we need to work. See, treatment differs from patient to patient. How do we give that particular precision healthcare support to an individual, where we need to work on. And the other side, of course, when we are depending more on technology, and technology knows everything about us and holds all the data, so we need to also need to look at the security, privacy, and ethical consideration, and ensuring that AI follows the compliances. So is an area where you can work on. And we can also look at AI for post-treatment monitoring and follow-up. So the treatment is done and a patient is back to home, but he requires a continuous monitoring. So for that, again, there are research areas where we can work, right? So with this, I end my session over here, and I'm open for any Q&A. And thank you. If
Participants,
there are
any
any
question?
questions, I would like to take. Yes, please.
I think so, no question, sir.
Okay.
So thank you very much, so Rajnikant sir, for your so valuable time you spend and given a lot of inputs to the so all the participants regarding so AI and IoT impacts on the telemedicines. Thank you very much, sir.
So thank you, sir. Thank you very much for the opportunity. And you know, uh, people who are doing research using AI in healthcare can always reach out to me for any kind of guidance required. Thank you.
Thank you, sir. Thank you very much.
Thank you. Thank you.
So dear participants, with this today's 2 sessions are completed. So I will share the meeting link and so tomorrow sessions. So what are the topics and who are the resource persons in our Telegram, this WhatsApp group. Thank you all. Thank you for your cooperation and the support. I think this feedback link is not activated in our so ATAL portals. So once I have submitted the attendance, it will be activated the feedback form. So last day of the session, I will submit the attendance. So that it will be enabled in our so portal. You can submit the final feedback. So one by one, please. Yeah, thank you all. If you have any queries, please text me in the WhatsApp. I will reply.
Sir, attendance process, please.
So from this, so teams I have downloading the attendance who are presented for these sessions. I will give the attendance directly in the ATAL link, sir.
Okay, sir. Can we give the names on chat also, or no? Not me.
If you are attended for this meeting, automatically it give the attendance, sir.
Okay, sir.
So
Okay, thank you.
yeah, directly I am downloading from the so Teams recording session. So it generates the who are the presentees are there. That names I will get it.
Hello, sir.
Okay.
Yes, sir.
Thank you.
Hello.
Yes, sir. Please.
Can we get this PPT after the session?
Yeah. I will share, sir. One PPT I have shared just now. So remaining
Okay.
resource person sharing that PPT, I will forward it.
Okay. Thank you.
Yeah. Thank you, sir. Yeah. Thank you all. Good night.